All right, so you guys wanted to know more about programming languages, really the foundation of everything tech that we use, you know? So today we're going to break down what they are, how they work, and why there are so many. You can think of it as kind of your intro to how the digital world functions.
Yeah, that's a great way to put it. And you sent over a really great set of resources for us to use too. We've got what is a programming language, which is great for the big picture,
Yeah.
and then some specific guides on Python covering like its basic principles and then things like variables, data types, and operators too. We really want to make sure we connect the dots for you, give you a clear understanding of how it all fits together, and also explain why Python is so popular these days.
Okay, awesome. So let's jump right in. We hear programming languages all the time, but what actually is one?
So at their core, they're basically tools that let developers like myself give instructions to computers. You can kind of think of it as like a shared language, with vocabulary and grammar that both people and computers can, in theory, understand. The computer does need those instructions translated into machine code, which is its native language. And just like human languages, different programming languages have developed for different reasons and have, different strengths.
That's a really good way to explain it. So we give these instructions, but how does that code actually make the computer do what we want?
Well, it usually goes through a few steps. So first, the programmer writes the code using a specific language.
Yeah.
And then the code has to get turned into something the computer's CPU can actually read. That transformation happens through either compilation or interpretation. And finally, then the processor actually follows those instructions at the machine level.
Okay, compilation and interpretation. Those sound like the big differences.
Yeah.
Could you break down how those work and maybe even touch on those examples from the What is a Programming Language doc?
Sure. So let's start with interpretation, because
Yeah.
that's actually how Python works, and that's a big focus for us today. So when you've got an interpreter and it sees a line of code in a language like Python, like let's say print, hello world, it'll read that one line, translate it either into like an intermediate form or directly into machine code, and then run it right away, line by line. So it happens as the program's running, it's translated and run on the fly. And this makes it really easy to debug, which is why interpreted languages are often used for like rapid prototyping or scripting, when you need to make quick changes.
So it's kind of like having a translator, reading a speech out loud, translating it sentence by sentence as they go along.
Yeah, that's a really good analogy. Now, compilation, that's different. That's how languages like C work. And we have that example in the sources you sent. So in a compiled language, you've got this program called a compiler, and it takes all the code and translates it into machine code before the program ever runs. And then that machine code is saved as an executable file. And the nice thing is this makes compiled languages really fast, so they're good for things that need to be super high performance like operating systems or, like high frequency trading platforms.
Oh, okay. So with that C example, the hashtag includes studio.h part and the int main part. All of that gets converted into one package that the computer can just run directly.
Exactly. That C code that you shared is a whole program, even though it's simple. The compiler takes all of that and makes a single file that can be executed.
Okay, I see the difference. So in the real world, what does it mean for a language to be compiled versus interpreted? What are the pros and cons?
Well, as we said, compiled languages tend to be faster, and their performance is more optimized because that translation to machine code happens ahead of time. But one of the big downsides is that you have to recompile the whole program every time you make a change, even a small one. And that can really slow things down when you're developing, when you're experimenting and making lots of tweaks.
Yeah, that does sound kind of annoying if you're constantly updating stuff.
It can be. Interpreted languages are better when it comes to debugging and cross-platform compatibility. Because the code is executed one line at a time, it's easier to find and fix errors as they happen. And if there's an interpreter for a certain operating system, the same interpreted code can usually run on different platforms without having to be recompiled for each one. The trade-off is that they generally run slower than compiled languages because, as we said, each line has to be interpreted as it's run.
So it's like speed and upfront compilation versus ease of development and the ability to run on different platforms. Now, the What is a Programming Language document also mentioned these hybrid languages. How do those fit in?
So hybrid languages try to take the best of both worlds. Java is a good example. So in Java, your code is first compiled into an intermediate format called bytecode. And this bytecode isn't specific to any one processor. It's meant to be run by the Java Virtual Machine, JVM, which basically acts as an interpreter for the bytecode. Python actually has a hybrid element too. It compiles your code into bytecode, and that's then interpreted by the Python virtual machine, PVM. And that bytecode step can actually make things run a bit faster.
Interesting. So it's not always a clear-cut either situation. Now, looking at this table of popular programming languages, it's pretty extensive. It seems like there's a language for almost anything you could want to do.
Yeah, exactly. And this table shows how different languages have evolved to be really good at specific things. Take Python, which we'll get into more detail later. It's listed as high level and interpreted, and it's become hugely important in fields like AI, machine learning, and web development because it's easy to read and has a lot of great libraries. Then you've got JavaScript, also high level and interpreted, and that's the king of web development. It handles everything from the interactive parts of websites to the backend stuff.
And then there's Java, which, like you said, is both compiled and interpreted, and it's used for a ton of Android apps and big enterprise software. C, which is procedural and compiled, works really close to the hardware, so it's great for system-level programming and building operating systems. Looking at this, what's a fundamental difference in approach between, say, Python and C++ that makes them so good at different things?
That's a really good question. So Python from the very beginning was all about being easy to read and fast to develop with. It's designed to be clear and concise so developers can write code quickly and understand it easily too. That makes it perfect for things where speed is key and you need to experiment a lot, like in data science and scripting. C++M, on the other hand, is about raw performance and having a lot of control over the system's resources. It gives you a lot more control over how memory is managed and how the processor is used. That's super important for demanding things like game development and high-performance computing, where every millisecond counts. But the downside is that C++ code can be a lot harder to write and debug than Python code.
Okay, so it makes sense why different languages are good at different things. It all depends on how they were designed and what trade-offs they made. So with all these languages to choose from, how do you even know where to start when you have a project in mind?
Yeah, that's a big question. The very first thing you need to do is figure out what your project actually needs. What kind of application are you building? How important is performance? What platforms does it need to run on? For instance, if you're making a website that needs to be super interactive in the user's browser, you're almost certainly going to need JavaScript. If you're working with huge amounts of data and building machine learning models, Python or R might be your best bets because they have those specialized libraries. If you're doing a mobile app for Android, then Java or Kotlin are good options. For iOS, you'd use Swift. And like we said, game development often uses C++ for its performance, or C# Ship if you're using the Unity game engine.
So it all comes down to what you're actually trying to build. What if you're just getting started with programming? The choosing the right programming language section suggested Python and JavaScript. Why are those good for beginners?
Both Python and JavaScript are good for people who are new to this because they're not as hard to learn as some other languages. And there are tons of resources out there for both of them. People say Python's syntax is really readable, so it's easier for newbies to understand how code is structured. It almost reads like plain English. And JavaScript is essential for web development, and seeing your code actually working in a web browser can be really motivating when you're just starting out. Plus, both languages have really active communities that are happy to help, so it's easier to find support when you get stuck.
That makes a lot of sense. Readability and being able to see results right away can be really encouraging when you're new to something. Now, we've mentioned Python quite a bit. Actually, most of the sources you've been using are about Python. So let's really dive into it. What makes it so special?
So Python is so popular because it has this combination of really great characteristics. Like we said, it's high level, interpreted, and general purpose. And the source, Python Programming Language, A Complete Guide, really talks about how simple it is, how easy it is to read, and just how many different things it can be used for. It's not limited to just one area. It supports multiple programming paradigms like procedural, object-oriented programming, OOP, and even functional programming styles, which means developers have a lot of flexibility in how they build their projects.
And it seems like it's used for everything from websites to AI to cybersecurity. That versatility must be a big part of why people like it.
Yeah, definitely. The specific things about Python, as that source points out, make it really appealing. Its syntax is simple, so it's relatively easy to learn and write code. It being interpreted means you can run your code directly without compiling it, which speeds up development. It's also cross-platform, which is huge. That means you can write code once and usually run it on Windows, Mac OS, and Linux without changing much. And it's dynamically typed, meaning you don't just say what type of data a variable is going to hold, which can make code cleaner and faster to write, especially for beginners.
Yeah, the source said, no need to declare variable types. We'll talk about variables soon, but that does seem like one less thing to worry about when you're first starting out. What about these extensive libraries the source mentioned? That seems like a big plus.
It's a huge advantage. Python has this incredible collection of pre-built modules and libraries that give you all sorts of ready-to-use functions. So for people working in data science and machine learning, you have libraries like NumPy for number crunching, Pandas for data analysis, Matplotlib and Seaborn for making visuals, and frameworks like TensorFlow and PyTorch for deep learning. For web development, there's Django and Flask, which make it easier to build web applications. In cybersecurity, you've got Scapy for messing with network packets, and Request for interacting with web services. And for automating things, there's Selenium for automating web browsers and PyAuto UI for automating graphical user interfaces. Having this huge ecosystem of libraries means that for a lot of common programming tasks, you don't have to reinvent the wheel. You can just use existing code that's already been tested and works well.
Wow, it sounds like no matter what you're trying to do in the tech world, there's a good chance Python and its libraries can help you out. Now let's talk a bit about the basics of Python syntax. The Python programming language guide uses the classic hello world example, which is just print hello world. That seems way easier than the C example we saw earlier.
Yeah, it shows how Python is designed to be readable and concise.
Hmm.
That print function is built into Python, and it's used to display output on the console or other output devices. That one line of Python code does what takes several lines in a language like C.
Okay, so that gives us a taste of Python syntax. Let's move on to variables. The Python Variables A complete guide explains those. So in Python, what exactly is a variable?
You can think of a variable as a name you give to a location in the computer's memory, where you store a value. That value can be different types of data, like numbers, text, or more complex data structures. And one important thing about Python variables, like your source says, is that you don't have to tell Python what type of data it's going to hold when you create it. Python figures that out on its own based on the value you assign to it, because it's dynamically typed.
So if I write x is supposed to be an integer.
Exactly. And if later on in your code you do something like x hello, Python will automatically change the type of x to a string.
That's pretty cool, very flexible. Now, I'm guessing there are rules for what we can name these variables, right?
Oh yeah, definitely. You have to follow these variable naming rules. So in Python, variable names can have letters, uppercase and lowercase, numbers 0, 9, and underscores, but they can't start with a number. And you can't use Python keywords, which are special words that have specific meanings in the language, like if, else, def, and class. And it's really important to remember that Python cares about case, so myvar and myvar would be two different variables.
Got it. Case matters. The guide has some good examples of good and bad variable names, which is helpful for understanding the rules. It also suggests using snake case. Why is that a good practice?
Snake case is what a lot of Python programmers do, where you write variable names in all lowercase and separate words with underscores. So instead of userage, you do userage, or total price would become total price. This makes your code so much easier to read, especially when variable names have multiple words, and it makes it easier for you and others to understand what your code is doing.
Makes sense. Readability is key. Now, the guide also talked about different ways to give variables values, giving one value at a time, giving multiple values at once, and giving the same value to multiple variables at the same time.
Right, so the most common way is just to assign one value to one variable, like x equals 10 or name equals Alice. But Python also lets you do multiple assignments on one line, as long as you have the same number of values and variables, like a, b, c equals 1, 2, 3. And if you want to give multiple variables the same value, you can just chain them together, like x, y equals 100.
That's pretty efficient, and it can make your code look a lot cleaner. And how do you figure out what type of data a variable is holding in Python?
For that, Python has this built-in function called type. So if you have a variable, let's say x equals 10, and you run print type x, Python will tell you class int, which means x is currently holding an integer. This is really helpful in a dynamically typed language like Python, where you don't say what type of variable is going to be up front, especially when you're trying to find errors or understand how data is flowing in your program.
Okay, so variables are like the containers for your data in Python. Now let's talk about the types of data you can put in these variables. The Python data types, looks like there are quite a few.
Yeah, Python has a whole set of built-in data types for different kinds of information. The Python Data Types Complete Guide breaks them down well. So first you have the numeric types, which include integers, int, for whole numbers like 100 or Navish 50. Floats, float, for numbers with decimal points like 3.14159. And complex numbers, complex, which have a real and an imaginary part like 2 plus 3j. One thing that's cool about Python integers is that they can be as big as you want, so you don't usually have to worry about them overflowing like in some other languages.
Hmm.
You can think of an integer like counting how many of something you have, like how many users there are, and you'd use a float when you need more precision, like the average rating for a product.
So Python just handles those potentially huge numbers behind the scenes.
Pretty much, yeah. Python manages how memory is used for integers automatically. Then you have strings, str, which are sequences of Unicode characters, basically in any kind of text, and booleans, bool, which can only be either true or false. Booleans are super important for controlling how your code runs, with conditional statements.
Right. Those data types seem pretty standard in most programming languages. What about these sequence types mentioned in the guide?
Sequence types are for holding collections of items in a specific order. The main ones in Python are lists, listus, which are ordered, mutable, meaning you can change what's in them after you create them, and can have duplicate elements, tuples, which are kind of like lists in that they're ordered and can have duplicates, but they're immutable. You can't change them once they're created. And range, which is an immutable sequence of numbers that's often used when you want to loop a certain number of times. So lists are your go-to when you need a collection that can change. And tuples are for when you have ordered data that shouldn't be modified.
So lists are flexible and tuples are more fixed. Got it. Then there are set types, and those are unordered, right?
Yeah, that's right. Set types in Python, specifically set and frozen set, are collections of unique elements, meaning there can't be any duplicates. The difference is that a set can be changed, so you can add or remove things, but a frozen set is immutable. Since they're unordered, you can't rely on things being in a particular order. Sets are really useful for things like getting rid of duplicate entries in a collection or doing math set operations like union and intersection.
Okay. Unordered and only unique elements for sets. Makes sense for certain things. Now, what about the mapping type? The guide mentioned dictionaries.
So the main mapping type is the dictionary. Dictionaries are awesome for storing and retrieving data in key value pairs. Each thing in a dictionary has a unique key and a value that goes with it. They were unordered before Python 3.7, but now the order of items is guaranteed. And you access values using their keys, kind of like when you look up a word, the key in a dictionary to find its definition, the value. Dictionaries are super versatile for representing data that has some kind of structure.
That's a good analogy with the real dictionary. And then there are binary types and the none type.
Yep. Binary types are for working with raw binary data. These include bytes, which is immutable, by in array, which is mutable, and memory view, which lets you look at binary data without copying it. You use these when you're dealing with things like files, network communication, or low-level data stuff. The none type is a special value in Python. That means there's no value there. It's often used to show that a variable hasn't been given a value yet or that a function doesn't return anything. So none basically means there's nothing here.
Okay, so none is like a placeholder for missing information. Now, we also talked about how you can convert between these data types using functions like int, float, and string.
Right. Python lets you explicitly change values from one data type to another in a lot of cases. So you can take a string that's a number, like 123, and turn it into an integer using int123. But not all conversions will work or make sense. For example, if you try to turn the string hello into an integer, you'll get an error.
Right, you can't magically turn words into numbers. Okay, that was a great overview of Python data types. So to actually work with these variables and data, we need to use operators, right? The Python operators detailed guide looks like it has all the info.
Yeah, operators are those special symbols in Python that do stuff to variables and values. Python has a ton of different types of operators. First, there are the arithmetic operators, which do math. These include plus, minus, bangs, times, divide, floor divide, which gives you the whole number part of a division, modulo percent, which gives you the remainder of a division, and exponent. So if you have a 10 and b equals 3, a perspe would be 1, because that's the remainder when you divide 10 by 3.
Right, the modulo operator is handy for checking if a number is even or odd, for example. What's next after the arithmetic operators?
After that, you have the comparison operators, which are sometimes called relational operators. They compare two values and tell you how they relate, and they give you back a Boolean value, true or false. You have equal to bay, not equal to, less than, greater than, or equal to, and less than or equal to. These are super important for decision-making in your code because they let you run different blocks of code depending on whether certain conditions are met.
So those are the basis for Eiffel statements and other conditional logic.
Exactly. Then you have logical operators. and, or, and not. These let you combine or flip Boolean expressions. So for example, by5 and y10 will only be true if both by5 is true and y10 is true, but by15 or y10 will be true if at least one of those is true, and not by5 would be false because it flips the result.
So and means both have to be true or means at least one has to be true and not reverses the truth.
Got it. What about bitwise operators? Those sound a bit more complex.
Yeah, bitwise operators are a bit more specialized, and they work on the individual bits, which are the binary digits of integers. They include A and D or XOR, not let.
Totally.
You'd use these when you're working at a very low level with the computer, like with embedded systems or network programming, or when you need to do very specific things with binary data. It's good to know they exist, but you don't need to master them right away. They're there when you need to manipulate data at the bit level.
Good to know. Now, we also had assignment operators, which are more than just the equal sign. Right. The basic one is the equal sign, which assigns the value on the right to the variable on the left. But Python has these shortcut assignment operators that combine math with assignment. So x plus 5 is the same as x plus 5. You also have mass and so on. These can make your code shorter and sometimes a tiny bit faster.
It makes the code less wordy. Then there are the identity operators, is and is not. Earlier you mentioned they're different from n-fel. Could you explain that again, maybe with another example?
Sure. So the key thing is that and fel compare the values of two things, meaning they check if the content is the same. The is and is not operators check if two variables refer to the exact same thing in memory. Remember our dictionary example. Imagine you have two physical copies of the exact same digital document. If you compare the words on those pages, they're identical, but they're still two separate pieces of paper. The is operator is like asking if you're looking at the same physical piece of paper.
That analogy makes it much clearer. So even if two variables hold the same data, it will only be true if they're basically pointing to the same place in memory.
Exactly. Finally, there are the membership operators, in and not in.
Those are for checking if a value is in a sequence, like a list or a string, right?
Yep. So let's say you have a list of fruits called fruits. Then apple in fruits would be true if the string apple is in that list. And mango not in fruits would be true if mango isn't in the list. They're really useful for seeing if something is part of a collection.
So very helpful for checking for a specific item within a group. Now, going back to something we touched on before, the guide asked, is Python case sensitive? And the answer is yes. Why is this so important to keep in mind when writing Python code?
It's important because it means Python treats uppercase and lowercase letters as different things. This is true everywhere in your code, like in variable names, function names, built-in functions like print, keywords like if and else, and even module and class names. If you mess up the capitalization, Python will think it's something completely different, and you'll probably get an error because the interpreter won't know what you're talking about. For example, if you name a variable username, you can't later use username. Python will see them as two separate things, and the function for printing output is print with a lowercase p. Using print with a capital P won't work. This trips up a lot of beginners, so paying attention to case is really important for writing Python code that actually works.
Okay, so it's all about being careful with your spelling and capitalization. One capital letter can make a big difference. Well, this has been a really informative deep dive. We've covered so much, from the very basics of what a programming language is to the details of Python's syntax, variables, data types, and operators. I feel like I have a much better understanding now.
That's great to hear. You now have a good foundation for understanding how programming languages work, the key differences between compiled and interpreted languages, and a good overview of the core parts of Python, which is known for being both powerful and user-friendly. Understanding that variables are containers for data, the different types of data Python can handle, and how to use operators to work with that data, those are the basic building blocks for anything else you want to do with programming.
So what's next? What can someone actually do with this knowledge?
Well, with all the Python libraries we talked about and how it's used in so many different fields like data science, AI, web development, cybersecurity, and automation, you can really do a lot with this foundation. Now you can start thinking about what kind of problems or applications you're interested in. Do you want to analyze big data sets to find patterns, maybe build interactive websites, automate boring tasks to save time, or even get into the world of AI? Python can help you with all of that. This deep dive is just the first step in a much bigger journey of learning how to use programming to make your ideas a reality.
This was a really great overview. I hope you all learned something.
Yeah, me too.
Until next time.
See ya.